Hi, in this video, I'll be solving this problem of writing the equation of this curve, given the 4 points, given the shape, and that it has a vertical asymptote right there. The question doesn't say what kind of graph this is, but it came from a section of book having to do with exponential and logarithmic functions. So I look at this shape here, and the fact that it has a vertical asymptote here, and I assume is a logarithmic function. In a previous video that I link up here, I already solved this problem once using algebraic methods. In this video, I'll be solving it using the techniques of graph transformations. Here's the approach. We know that this is a logarithmic function. So we know that the original, or some people call it the mother curve, is y equals to log base sum a of x. So this is our approach. Our approach is to go from this graph to the graph of y equals log base a of x graphically. And then from there, we go back to this graph with an equation. That's the approach. Let's look again at the mother curve. Y equals log base a of x. It looks like this. There are three things about a logarithm curve. Number one is that it has a vertical asymptote at x equals 0, or the y-axis. Number two, it passes through that point. X equals 1, y equals 0. And the third thing is it passes through this point up here, where the y value is 1 and the x value is the base. Our goal is therefore move the given curve, the curve that we're given, the red curve, move it around so that it fits this picture. Let me copy this graph onto a clean page and we'll continue. I have three goals. First goal is to have a vertical asymptote at x equals 0. Right now, the vertical asymptote is at x equals -5. So I need to move it to the right by 5 in order to get to x equals 0. That means I want to translate to the right by 5. So if I translate everything to the right by 5, then this point 3, 3 is going to get to here. This point will get to here, here, and here. I will end up with 8, 3, 4, -1, 2, -5, 1, -9. And I get this new curve. That solved the first step, which is to get the vertical asymptote at x equals 0. Now I want to have the point 1, 0. I want that point 1, 0 right there. Well, right now I have 1, -9. If I want 1, 0, I will need to push the graph up by 9. So I want to translate up by 9. All of these points will also get translated up by 9. This first point is 1, 0, just like I want. This point will be 2, 4, 4, 8, and 8, 12. All right, this picture is starting to look kind of messy, so let me copy all of this down on a new page down here. So this is where I am roughly. Now I want to somehow get to a point where the y coordinate is equal to 1. Then that would just get me the x coordinate as the base. I have 4 points to choose from. This point is going to have to stay fixed. Therefore, I can't do translation anymore. If I want a point on the x-axis to stay fixed, what I will need to do is to scale. I will need to scale so that one of these points go down to 1. I could take the 2, 4 and bring it down to 2, 1. I could take this point and bring it down to 1, or I could take that point, bring it down to 1. You can tell that each point will give me a different base, right? So how do you know which one to use? Well, as it turns out, it doesn't matter. You bring down a different point, you get a different base for now. But later on, when you use algebraic method to go back to the original curve, it will even out. So it doesn't matter which point you choose. I'll choose the point 2, 4, and I want to bring it down to 2, 1. You should go ahead and try choosing one of the other 2 points and tell me if you got the same final answer. But I choose the first point, so I will squish. The technical term is to contract by a factor of 1/4. So I squish it down by a factor of 1/4. This point will be 2, 1 like I want. This is going to be 4, 2 and 8, 3. And then I have my y is equal to log base a of x, where a is this number right here. So that's log base 2 of x. So to summarize what we've done so far, we translate to the right by 5. We translate up by 9. We squish by a factor of 1/4. And we arrive at y equals log base 2 of x. Let me copy all of this down to a clean page. I start with the given curve. I do these 3 things in that order. Then I end up with y equals log base 2 of x. So now if I want to go from log base 2 of x back to the given curve, I will need to go backward, reversing each transformation. So that means first I need to multiply vertically by 4 to reverse the 1/4. And then I need to translate down by 9. And I translate left Let me slide this over here. Let's do it. If I start with log base 2 of x and I multiply vertically by 4, then that means I have y is equal to 4 times log base 2 of x. And then I translate down by 9. So that means I'm going to subtract 9 over here. And now I translate left by 5. That means I'm going to replace x with x plus 5. And that's my given curve. Let's check our answer. We're given 4 points, 3, 3, negative 1, negative 1, negative 3, negative 5, and negative 4, negative 9. For log base 2 of 3 plus 5 minus 9 is equal to 4 times. Log base 2 of 8 is 3. because 2 cubed is equal to 8. 4 times 3 minus 9. 12 minus 9 is equal to 3. That works. 4 times log base 2. Log base 2 of 4 is 2. Because 2 squared is equal to 4. -1, that's correct. 4 log base 2. Log base 2 of 2 is 1. -5, correct. And then the last point, 4 log base 2 of -4 plus 5 minus 9. Log base 2 of 1 is equal to 0. Log any base of 1 is 0 because any base to the power 0 is always equal to 1. So this is 4 times 0 minus 9, which is equals to -9. All the points check out. My solution is confirmed. Hope that's been fun. Any questions? Please put in the comments. Subscribe for more contents. Thanks for watching. Bye.